Alright, so in this video we'll be assembling our gearbox. So last video we made the first plate, here it is, and so let's start an assembly. So new assembly, here we are. So we'll place our file. So here we go, there's the first plate, open it, and we'll place it here. Right, so we have our symmetric planes here, so we can use that to secure it in place because right now it can move around, or we could just ground it. I'll do the planes right now, so we can do that. And you can see if it's in mate, it'll go like upside down, but if you click flush, it'll be the right way. So we'll do that. Then we'll do the YZ planes, and we can do the XZ, and there we go. So now our plate is constrained in place, and you could have just done that by grounding it, but I like using planes. And so now let's start adding stuff to it, right? So remember, we have bearings over here, 2 motors, gears, and screws and things. So why don't we start with some motors? So we'll go place, we can go to our parts library, motion, motors, and we're using the Falcon motors, right? Because go on JVN, that's what we are using here. So we're going to use 5.500s. We'll click open. Did it not click open? There we go. And we'll place 2 of them. Right, so it's hard to see, but if you zoom in, you can see like the 6 different holes where you can mount the Falcons. And so what we'll do is we'll hit constrain, and we can pick any of the holes we want for now. Generally, if we're trying to model this realistically, you would pick the hole depending on where the wires are going, because in real life you want to make sure that your wires are going in a direction where it's easiest to connect them to the rest of the electronics. So, but that doesn't matter for right now. So so if you zoom in, you can select this top hole. We'll select that, and we will select the back of this plate. So if you go to the back of this plate, remember these 2 smaller holes are for the motors. So we'll hit that one, and you see the motor goes in the right place. And we can select the second motor mounting hole, and we'll come back to our motor that's over here, and we'll place, and we'll click on this circle here. Again, it's like this, that one, and there are 2 motors over there, right? So we can hit apply, and now our motors are the equivalent of if you had a screw in only one hole. They can rotate around, but they're in the right place. So the next constraint we can do, we just need to get it in the right place. So all we need to do is do constrain, and we can select the inside of this hole here. So it will be the axis over here that goes to the motor, and the axis of this hole over here, and those 2 match up. And this is also confirmation that your motor mounting holes and the center hole are correct according to the motor, because if you made these dimensions incorrectly, it wouldn't let us constrain it that way. So we can do the same thing here. Now you could technically do another insert constraint. So we mounted it to that hole here, which means the opposite hole will be that one, and we can do constrain, insert, and we can pick this hole over here. Alright, so that's circle there, and we can pick this second mounting hole, and as you can see, the motor mounts there as well. So you could do either of the 2 options. I find the first one, when you use the axis over here, that one tends to be a little bit faster and easier to do, but you can do either one. So we have our motors here. Right, the next thing we need are the 4 screws for these motors. So we can go place, let's go back to hardware, screws and nuts, and the motors mount using 10/32 screws. And right now we have a 1/4 inch plate and then the motor. So in this orientation, what we'll need is 10/32 that are 1/2 inch long, right? So you can see we have a couple of options here. So we have a 1/2 inch button screw, which as you can see has like a button head on the top. We have countersunk, which has this like Y shape almost. We have a low profile, which has a thinner head on it, and we have a socket screw. So socket screws are standard, right? As you can see, it's a standard screw. Low profile means that the head is a little bit shorter, so if you have a really tight space, these screws are great for that, but they also tend to be a little bit weaker. Countersunk, this Y shape allows you to have it flat against your plate, so with the socket screw, this extra bit over here sticks out of the plate. With a countersunk, you can make this like Y-shaped hole, and this whole thing will sit inside your plate. So it's used in some applications, not over here. And then button head, basically it's a little bit weaker than socket screws, but it has a larger surface area, so it can have an application there, and it's also a little bit thinner. So it's like it's in the middle between low profile and socket. Low profile is small and has the least amount of strength. Button heads are in the middle, and then the socket is like the strongest. So in this case, we don't really care that much about the space because we have enough space, so we can just use the socket screw. And also socket screws tend to be a little bit cheaper, so it's easier to get these in bulk. And then what we're going to do is constrain. Again, we can use the insert constraint. And so if we zoom in on the screws, there's this circle here. That's what we want to select. And we want to go on the motor holes, do that, and there we go. So we can just do that. Oh, I selected the wrong one. So if you select the wrong circle, for example, you can either just cancel the constraint, or what you could do is go here and click on one. So this one just means the first selection. So I can click one again and it'll let me choose my first hole again. And so we're on the second one. Let's select the screw, and there it is, mounted. Right, so given that I have this middle plane here, I can just mirror these two screws over, right? So what I'll do is do mirror, and we'll select these two screws over here. Now if you see these, there are these three green circles over here, and if I click on them, they change to yellow, and I can click on it again to make it gray. So what does all this mean, right? So when you're mirroring components, green basically means that Inventor will create a new file for those components. So in this case, it would create new files of these screws. And the reason why it might create new files is if you have asymmetric parts. So if you're mirroring an asymmetric part, right, the other part, it's not the same thing. You can't just rotate it around and it'll match because it's asymmetric. You can't mirror it across a plane. But for something like screws, motors, gears, bearings, all these components, they are symmetric. I can just copy these screws and paste it on this other side, and that will also work. So in this case, we don't need to create new files. So we can just check it so that it's yellow. Now the gray basically means that in case you selected something accidentally, you don't want to mirror it, you can make it gray so it won't actually mirror it across. Right? So if we select the YZ plane to mirror across, as you can see, I made this one gray, and so that screw doesn't show up, but the moment I check it, it shows up there again. And if you don't want to select like 10 different components, you can just click the topmost one and it'll change everything, right? So we don't want to create new files, and we'll make ground new components because when it mirrors things over, it won't automatically constrain it to the plate here, so the screws will be able to move around. We don't want to move around, so we'll just do ground new components. We'll hit next. And this is where it will tell you the file names if you were creating new files, but we're not, so we can just do OK. And there it is, right? As you can see, they're grounded and it's in the right place. Right, so the next things we need are the bearings over here. So we can go again, place. Let's go back to motion, bearings, and we want to select these hex bearings here, right? So we'll do hex bearings, open, and we can place them here. Right, so now we're going to constrain them. So we'll do an insert, that hole, and we want the outside of the bearing there, so we'll just do the circle, and there it is, apply. Let's do another insert, there we go, and we can hit apply. Right, so there are our bearings that we needed there. And so what else do we need now? Oh, we're missing the gears, right? So if you look here, we have the 9 and 44 gears. That's our first set of gears. So let's place them. So if we go here, place, let's go back. And if you look in motions, there's under gears, there's all these different categories, right? So the 9-tooth, remember, it's not a normal gear. It goes onto the motor, not a hex shaft. So we go on Falcon 500 motor gears because we're using a Falcon 500, and we want the 9-tooth gear. Right, so we'll click on the 9-tooth one, hit open, and we'll place 2 of them, and now we can constrain it. So we'll hit constrain, and we can do an insert constraint or an axis one, but I'll just use insert. And if you zoom in on the gear, and if you click any one of these like spikes, you'll see it's actually like curved, and so you can get an axis from that. And there's no circle, but there's this little bit of arc that you can use. And we can constrain it to this outside, but obviously that doesn't work. So what we want to do here instead is we'll do opposed, and we can, as you can see, there's a lot of space here that's unused, so we want to add an offset here. So maybe we'll try 1/4 of an inch, and there's still a little bit of space actually, so we can do 1/4 plus 1/8, and that actually looks good enough, so we can just use that, hit OK. And for the second one, we'll do another insert constraint over here, we'll constrain it there, opposed, and our offset was again 1/4 plus 1/8. Hit apply, and there's our 2 9-tooth gears. Right, the next one we have is a 44, I think. Yep, it's 44 teeth. So we'll go here, place, and this time we want the gears that go in hex shafts. So there's 2 sets here, right? So hex gear with Versa keys, basically these gears have a, oh, what? These gears are gone. Okay, there used to be files here, they're gone for some reason, but basically Versa keys, they have holes in them along the sides. We don't need that, so we'll just do hex gears over here, and we want a 44 tooth, so we'll hit open, and we'll place that one. There we go. So now we can do constraint, insert constraint, and on the gears, if you look, right, there's these little ridges on each side, so we don't actually need to place a spacer here against the bearing, because if these ridges weren't there, the whole face of the gear would be rubbing against our metal and our bearing, and we don't want that, so you would add a spacer there. But because there's this ridge here, we don't need to add a spacer. It basically works like a spacer. So we'll do an insert outside of that ridge, and we'll pick the bearing outside over here, right there, and there's our gear. And as you can see, if you look from our front view, our gears are meshing together correctly. If you just spin the gears right, you see that they're meshing correctly, and that's because we used the pitch diameters in our initial sketch. So that's why it's important to do that, right? Okay, let's look at our next gear. We have 22 tooth and a 40 tooth. So we'll place a 20 tooth. So now we're in the right folder here, so we can just do 20 tooth, hit open, right there. And actually, for 22 20 teeth gear, we would generally use steel gears because they are pretty small, and we've had problems in the past when the gears just like burn away. So we want to use a steel gear. As you can see, just different in color on CAD, but it's made out of steel in real life, so it's a little bit stronger than the aluminum ones. And we'll do constraint insert, so we pick the outer, so these gears also have a little ridge on them, it's just a little bit smaller, and then we'll select this outer ridge, and there they are, hit apply. Now if you want to, you could line up the 2 or like 3 hexagon profiles, but the bearing, the gear, and the second gear, but you don't have to do that because you don't check that, and that doesn't give you any new information about if these 2 gears are colliding or something, so it's not necessary. Right, on the bottom here, we need a 40 tooth gear. We'll go back, 40 tooth, open, place it here. Now if I were to do an insert with the bearing, obviously that's not going to work because it's not going to mesh with our gear over here, right? So we need to be able to create an offset here somehow. So what we're going to do is we're going to add a spacer here. So we'll go place, and let's head back to hardware, and if you go under spacers, oh no, not over here, if you go spacers and standoffs, we can find our hex spacers here. So we go 1/2 inch. So the reason why I want 1/2 inch hex spacer here is because we have a 1/2 inch hex shaft and it's 1/2 inch long. Now I'll tell you why it's 1/2 inch long. So all these gears, they have the same width to them. So if we go on tool, measure, and if you measure the distance from this ridge to that ridge, it's 0.498, or basically 1/2 inch. We can do the same thing with this gear that's over here, right? We measure these two ridges and it's 1/2 inch. So that's why we're using a 1/2 inch spacer here, right? So we'll go back to assembly, we'll do constrain, insert our spacer along with the bearing. There's our spacer. And so now you can see if I do an insert to the spacer, my gear would be placed correctly. So let's actually do that. So constrain, insert our gear over here to the spacer. There you go. And now if you look from the side, our gear is in the right place and doesn't interfere with this other gear. And we're really close to the spacer, but we're not actually hitting it. So that's a good thing. So there's our 2 sets of gears, and that's complete, right? So we have all our gears. Now what are we missing here? So what we're missing are these 2 sprockets. All right, so we'll go over chain in another video, but let's place some sprockets. So we'll go to motion, sprockets. I don't want to rename it. And for drivetrain, we use 35 chain because 35 chain is stronger than 25 chain, and we want this chain to be reliable because you want to be fixing it every match and so. And then for the size of the sprocket, using bigger sprockets means you can take more load, but in this case 12 tooth sprockets, the smallest ones available, they're just fine, they work just as well. So we'll just use this one. So we'll place it, and we need 2 of them because we're driving 2 other wheels, right? So we have these, and so the way we can place them is we can do constrain, insert. So we want the back circle here, and it goes on top of the gear ridge. There it is. There's our first one. Now if I were to place the second sprocket over here, let me get in the right orientation. So if I were to place the second one here like that, what we have noticed is if you place 2 sprockets next to each other like that, or like that, let me do an insert. So if we were to just place these 2 sprockets like that, as you can see, the 2 sprockets are really close to each other, and the chain would actually, like, the chain on this one would run with the chain on the other one. It would rub against it, and we don't want that. So instead what we'll do is we'll add a spacer here, and we need just a little bit of space so that they don't run into each other. So go hardware, spacers and standoffs, and this time we'll pick this spacer over here. So again, it's 1/2 inch hex, but it's 0.0625, which means a 1/16 of an inch. So we'll pick that one. As you can see, it's far thinner than the other spacer we had. And you can do a constrain, insert that circle, and these sprockets, if you go around the edge, there's a circle there. So you can click that for constraining, hit apply, and we can do the same thing that we did before with the gear and the sprocket. So now what we have here is this 1/16 of an inch spacer, which will make sure that the chains don't collide with each other. So that almost looks done actually. What we're missing here is the second plate and the bearing and the spacer here, right? Because again, if I didn't have the spacer, my sprocket would be rubbing against my bearing and the chain would be rubbing against this plate, and we don't want that. So we'll go in here and we'll add another spacer. So place, and this time we can use a 1/4 inch spacer. So again, 1/2 hex and 1/4 inch in its thickness. So there it is, and then we'll constrain it the same way. So insert that circular thing over there and this circular axis. There they are. Hit OK, and so now we have our spacer. Right. So the final things that we need are bearings, because then we'll have our second plate over here. So what we can do is we can just take these bearings, Control C and Control V them, so they're copy pasted over here, and we can do a constraint. So we can do insert this part of the bearing to this part of the spacer, and there we go. Alright, so that's our bottom set of like all the stuff that's going to go in the hex shaft. That's complete, and we need a bearing above here, right? So as you can see, we can't just add a bearing to this gear over here because the second bearing should be on the plate as well. So what we need here is a spacer. Actually, we need multiple spacers because it's more than 1/2 inch, right? So the way we can do this is we'll take this bearing Control C, Control V it. So we have our bearing there. Now we want these two bearings to be on the same exact aluminum plate, right? So what we can do is we can do a flush constraint. So we'll make these two bearings and their ends flush so that they would go inside the same plate, right? You can see that they line up. Hit apply. And now the second constraint we can do is to line up with these gears. So we'll just do the axis of this bearing, so this big circular face over here. Oh, we don't want to do flush. So we'll do the big circular face, and we can pick, so we can go on the gear ridge and we can just pick that as a circular axis. And you can see now it lines up with the gears and it's on the same level as this other bearing so that it goes in the same aluminum plate. And we can hit apply. Right, so now what we want to do is we want to figure out the spacing between this gear and the bearing. So we'll go Tools, Measure, and we'll select this face over here to this face of the gear, and it's 1.157. Right, so 1.157. So what we can do is open up a calculator and see, so 1.157, and spacers come in whole numbers. So we'll subtract 1 inch. We're left with that, and then now we'll subtract an eighth of an inch, so it's 0.125, and we're left with this really small 1/32 space. So what we could do is we could either 3D print a spacer here for this exact dimension, or we could just place the best spacers that will work here and just use that. So it was 1 inch and an eighth. So here are 2 half-inch spacers. As you can see, 2 half-inch spacers and 1 1/8-inch spacer. So we'll do constraint, and the first thing I'm going to do is I'm going to constrain all of these spacers together to each other. So apply and apply. So we have this one big train of spacers, and we can just attach that to the gear, for example. Hit apply. So as you can see now, we should have 1/32 or 0.032 of space over here, which is what we have. And so there is that. Right, so what are we missing now from this? The next thing we need would be the plate or these standoffs here and the screws. Right, so these screws are 2.75 inches. Another way you could measure that is if you go on Tools, Measure, and we measure this bearing. So if we do this place over here, right, and this face, that's 2.52 inches. Right, so 2.5 inches, 2.526, plus a 1/4 inch aluminum plate. So we're about at 2.776, right? And if you subtract 2.75 from it, it's a very small number. So we can use a 2.75 inch 1/4 screw here. So we'll go Assemble, Place, and let's go back to Screws, 1/4, and then 2.75. So again, we have 3 options here: button head, countersunk, or socket. Socket offers the most strength, so that's what we're going to use here, 2.75, and we can place 4 of them, or you could do 2 and mirror them, but I already placed them, so I'll just do all 4 of them. So in these ones, the thread does not go all the way up, so there's actually a circular axis here. We can use that one and constrain it to these holes here. So we're going to hit that and apply, and we will hit this and over here, apply. Let's get the screw over here and over here, apply, and let's do our final one, which is over here, and it's already up there, so apply. So there's our 4 screws, and as you can see, they're pretty close to the gears, but if you put a standoff on it, they shouldn't touch if our sketch was done correctly. So next thing we need here are the standoffs themselves. So these standoffs, if we do a tool, measure, this is the existing gearbox, but the spacing generally ends up being the same. So these standoffs here are 2.276, and you need them to be the exact dimension, because otherwise, you know, this plate would run into the stuff over here if these are not the exact dimension. So that's why generally with gearbox standoffs, we make them ourselves. So this would need to be, again, it's the same dimension, 2.276. So let's make these standoffs. So we'll do new and we can do standard.ipt, create, and standoffs are just two circles, so dimension these. The outsides is 1/2 inch, remember, if you remember from the layout sketch of the gearbox, and the inside would be, it allows a 1/4 screw to go through it freely, which if we look on our dimension chart is 1/4 closed fit 257. There we go. Right, so we're going to use that here, 0.257, finish sketch, and we're extrude this outside profile, and the dimension was 2.526, I think it was. We can check again. So go measure here to here, 2.276. Oops. So extrusion, we'll edit this. You can double click on it to edit it. 2.276. Hit OK. There it is. We can make the material aluminum because that's generally what we use if we make our own standoffs. There it is, and we can save it as standoff. There it is. And so let's place that components in place. Let's go to our workspace and CAD challenges, standoff, and there it is. So I'll place 2, and actually we'll do all 4. So we can constrain, insert, let's pick a circle in the standoff, and that circle there, apply. Just do that 4 times to each of the screws that attaches the gearbox together. Apply. And you can select the outer or the inner circle, they're both the same place, so it doesn't matter. And we'll select this screw over here and hit apply. Now, if we look from our front face, as you can see, these standoffs are very close to our gears, but they don't hit them. And the reason for that is our layout sketch, we made that dimension 0.1 inches bigger so that they wouldn't hit it. And so this is exactly why layout sketches are important, and you can check for these kind of things before having to CAD all of this, right? So there's that, and that's good to go. And so the final piece here would be the hex shafts and the second plate, which we'll do in the next video.